Oh, let me check if my audio is going through as expected while I look around like a chipmunk. I can hear myself. I'm just making sure if this is the right mic or not. Cool, it is. I had the volume down low. Perfect. I'm just surprised I haven't messed up in a long time. Hey everyone, welcome back to the paper live streams. Today I've set an even more ambitious agenda. We're covering 7 papers today because I set the agenda for 4 and this is chai time. This is how we do things here. So we'll cover 7 papers today and let's see how that goes. Uh, see Chandan in the chat. Hey Chandan, thanks for joining. Good evening to you as well. Cool. So we're doing this on a Friday because honestly I have no life. There's no other reason. So let's just jump into it. Here's the agenda for today. I had promised to cover different domain specific large language models, and that's what I'm aiming to cover broadly today. So, in the description of this video, right under the like button, you can find all of the papers I'll be covering, at least the names of it. There's the broad topics would be finance, law, medicine, and also as broad bonus topics, I'll be covering robotics, English, and knowledge graphs. So I'm just setting up my tabs here and trying to lose all the notifications. Cool. So what I'll do now is I'll give a gist of different papers. I've been writing about these on the internet. So what I'll do is I'll cover the summaries of different paper, and instead of giving you exact details of all the papers like how we usually do, I'll just give you the important details from all the papers as in like a very high level overview. Most of the domain specific papers, at least from the early days, were like they would take a data set, they would fine tune llama, bloom, something like that on a domain specific data set, and there you go. Then you have like a very domain specific LLM, and that would of course outperform chat GPT 3.5 or whatever they were comparing to. The evals are also set in that way. So if you remember chat doc, I think chat doctor or something like that was the first llama based medical paper that came out, and since then there's been a lot of them. So wherever I see interesting ideas worth pointing out, I'll point those out, but otherwise I'll also like give a broad overview. So wherever I see, hey, it's like the same thing of fine tuning, we'll probably glance over it. That's the agenda for today. Surbit is saying he's super excited for this. I am as well. Cool. Let's just jump into the summaries first. So let's start by ChatLaw, which I posted about yesterday. Twitter has changed the setting where you could preview tweets. So now I'm sticking to LinkedIn, but regardless, I post paper summaries every day on both of these websites. So what I'm going to do is just read through the summaries and explain stuff that might not be exactly clearer. ChatLaw is the first, at least to my knowledge, open source LLM for legal applications. And this one goes beyond just fine tuning. It also has this very neat trick. Some people on Twitter pointed out that this is not the first time this trick has come up. It's existed before as well, and I think someone had linked off a Amazon paper or an Amazon article that does something similar. But still, at least it's the first time I'm seeing this, so it's still worth covering. Hey Saurabh and Santosh, thanks for joining. So here's the architecture. Now, most of the other open LLMs or even domain specific LLMs have this single LLM that is fine tuned. This one sort of has 3 different language models. So the ChatLaw LLM is the main mega brain. So that's the controller, and the user sort of interacts with this main LLM. Now, this is following the same approach, similar to think visual chat GPT or hugging GPT, where this mega LLM would sort of contact other small LLMs, right? Or small domain specific models, let's say, or smaller models. So, exactly how this model behaves as well in that way. It's quite similar to that. So, what it does is you sort of interact with ChatLaw. the main language model, which is based on Open Llama. And also kudos to the author. This is the first time I've seen Open Llama based open source model come up, and personally, I'm curious to see more. But for those of you that are not aware, Open Llama is this epic approach where they're trying to make a completely open reproduction of Llama, in the sense that it's trained on Red Pajama dataset and the architecture remains the same. So it's more usable. There's only one catch. I think some of these models don't behave well with code because of the tokenizer. That's the only catch. But regardless, I think it's still a very cool approach. So you have this main module, and after that, you have two different modules. So one is the keyword language model, and inside the paper, I couldn't find more details around this, but broadly, it extracts specific keywords based on your queries. Now, normally, when you're doing embedding lookup, what you would end up doing is you would have a query and then you'd perform cosine similarity lookup over the entire vector DB. The most similar top K answers sort of get returned. And before that, you of course chunk the entire data set, you store it in a vector DB, and later on you retrieve it. I'm being very broad, there's like more details to it, but broadly that's what happens. In this case, first thing that they do is they extract keywords from your queries, right? So they find the different specific jargons that that can be passed on to the module to look up these embeddings. After this, they have a BERT model fine-tuned to do like a phrase matchup. So it further generates embeddings from these extracted keywords and sentences, which are then used to do the embedding lookup. So just to repeat myself, you extract the keyword, then you have a BERT model fine-tuned to sort of do this similarity matching, from where you generate another embedding based on this keyword and the sentences, and then you do the lookup after running it through the BERT specific model, the special fine-tuned model. I think this like very fine step sort of sets it apart. This was the first time I read it, but some people pointed out it's existed before. This sort of helps minimize hallucinations. To what extent, that's like an open benchmark, but that's about it. They train this on the Chinese legal system, so for that reason I didn't read about the specifics much, although I am very fluent in Google Translate, and I Google translated the response in the paper. They seemed legit enough, at least to my like novice eyes, and I moved on after that. But at least this part was quite cool about it. This, to my knowledge, is the first open source legal application LLM, and I'm happy to be corrected about this. Cool. Moving on. This is a bonus coverage. So first, again, for anyone that's new, I'm going to be covering these summaries, and then we'll go to the papers and find specific details inside the papers as well, if there are any worth pointing out. But that's that's the broad agenda for today. Yeah, there's not much details around the keyword LLM, but I assume I'm just thinking out loud here. I don't think even GPT-4 is really good at extracting keywords for specific domains, right? So maybe you tune a BERT or DeBerta model for that, and that sort of summarizes it to give you keywords. So the summary is supposed to be one word. I don't think it is NER. I don't think it's that simple. I would I would hope so, because they in the paper, right, they called it a large language model, right? I mean, they also called BERT a LLM, which is kind of funny in the paper. And then I like went back and checked if they indeed did that. Yes, BERT was a LLM there as well. So I would hope that they're at least using a language model. So domain specific embeddings fed to reduce hallucination. I mean, yes, broadly you're right, but the trick is finding these specific words to look up, right? Normally you just do like a cosine matchup. So that's at least that's my understanding of it. I have no idea. So inside the paper, they don't clarify that. They have open sourced their code, but the readme was in Chinese, and then I didn't bother with looking at the code. Although they do have the code being open source. Let's just take a look in interest of everyone, or in interest of Rajesh and Maruti. Let's just do that. ChatLaw archive. Here we go. Data. So we have the data set right here, and let's take a look at the demo. No, I don't think they've open sourced that part yet. Maybe they're planning to. I'm not sure. They do have a demo right here, but again, that doesn't give us much details around this. If anyone has the interest, please could you all just Google translate this and let us know? That might be helpful. And let's just leave a star here. Cool. So that was ChatLaw. Now I'm going to quickly cover Chat GPT for robotics. This is like a very broad paper, and I think I might come cover more details once you get to the paper. But it's called Chat GPT for robotics, and all they do is they combine GPT 3.5 with some clever prompting, and knowing its limitations and understanding of the real world, they apply it to drones, robotic arms, and even simulations. So the cool thing about this paper is they also have an air sim module where you can like sort of connect it to a simulator and work with that. But that's about it. The cool thing, at least for me, from this paper was thinking out loud that hey, to what extent can we sort of apply large language models to even like real world agents or real world robots? And then I remember watching Tesla's presentation, right, on the Hydra net, and I was thinking that's sophisticated enough and is able to run on the car's hardware. But maybe that could be simplified a lot, right? You could just have like I don't know, like a canny edge detector or something like that, much simpler, connected to a LLM. So in that sense, I don't. I'm sure many companies are looking at this, and it's also sort of unreliable. These models aren't exactly very accurate. But that was my thought from this paper, at least. Yeah, I agree. It's quite a fancy way of doing the embedding lookup, but still worth a learn. Cool. We've already done 3 papers. Everyone, we're moving on to the next one. I promise to also cover these in more details, but I think I'm giving enough details around the summaries. So this one is called "Textbooks Are All You Need," and this is for creating code-specific models, and especially outperforming models with 100 times smaller data. So the paper takes a look at a 1.3 billion model that outperforms larger models. The catch is it only does that on writing Pythonic code. So that is the only catch here. Still, in even in that sense, right, a 1.3 billion model is still quite good, I would say. So this sort of derives its learning from the tiny stories paper, and it sort of creates a data set similar to how humans learn. And it only tackles one challenge, which means it's also sort of evaluated on only this one challenge, which is writing Pythonic code using doc strings. So you're provided with doc strings, and then you're supposed to write the functions. So the first thing that they do is, I think the fine tuning bit is interesting, so that's why I'm covering it. So they do this by creating a data set consisting of open source repos. The paper has the exact details. You can read about it. After that, they use GPT 3.5 to create simple exercises constrained by beginner friendly topics. The first few models are trained on a mixture of both of these. After this is like the really cool part for me. They create a set of exercises on which the same model above is fine tuned. And when they do this, when they fine tune on this like exercise data set, the model starts showing emergent abilities. In the sense, like it's not able to reason about world poverty, hunger, all that, world hunger, poverty, so on and so forth. But it's able to like connect to points beyond its training data set. That's like, let's say it's able to understand Pythonic APIs or write code for APIs it's never learned of. So that was the cool bit in this paper for me. It's titled Textbooks Are All You Need. That's the title of this paper. What is that? Emergent abilities. Emergent abilities, it's like a broad discussion, but in a very simplistic fashion. Whenever you're training these language models, right, when they start showing abilities that are beyond their training data set. So let's say GPT-4 is able to reason and in some ways think as well, right? So that is an emergent ability because it was not trained to do that, but somewhere along the training pipeline these models, large language models, start to show this emergent ability somewhere along the training graph. And then there was a paper that are these a mirage, maybe emergent abilities are fake. Here's the paper, but I leave this as a homework to you. It's quite an open discussion around, hey, do these even exist, or are these just like a leakage in the evals? So that's what emergent abilities are. Now here's the next paper, and this I'll just cover in a minute. It combines LLMs and knowledge graphs, and it suggests doing that in three ways. So when I picked this paper up, I assumed it would just be prompting GPT-4 and you'd probably like just connect an external knowledge graph to it. To my surprise, I wanted to read this paper in an under an hour, but it took me 3 or 4 hours to just get around this paper. That's because like really detailed, and I don't even think it mentions ChatGPT anywhere inside of it. So I got quite curious about this paper. It suggests three effective ways of combining these. The first one is knowledge graph enhanced LLMs. So here the knowledge graph acts like a secondary model and the LLM is like the main interactive module. So you're talking to the LLM and it's connected to this external module of a knowledge graph. Once you get to the paper, I can show you more details around this, but this is just the high level summary of it. After this, there's the LLM augmented knowledge graph, where the knowledge graph acts as a main interface, and then the LLM sort of provides embeddings or completions or generations, so on and so forth. So two different ways: either you interact with the knowledge graph or you interact with the LLM, right? And then finally, it's a synergy of both. Very broad classification, right? This doesn't even make sense broadly speaking. But inside the paper, it had like pages and pages and pages of different models that have sort of originated throughout the history of these models as they have existed. So if you're curious, you can read this paper. It talks in length about knowledge graphs. I didn't even exactly know what knowledge graphs were before reading this paper. That's about it. So now, for a quick recap, I want to show you all how you can sort of train these models. Let's say, you want to enhance your LLM with knowledge graphs, or even if you look at ChatLaw, I've covered this quite a few times. You can find it under the like button. This is H2O LLM Studio, fully open source and a no code way of fine tuning your language models. I just have a toy data set loaded in here. That's because I have so many instances. I'm sure I have like the right data set somewhere, but I usually just end up showcasing this one. So what you end up doing here is you load in your data set that basically contains instructions and their outputs. And this is known as instruction fine tuning. So anytime you hear about instruction fine tuning, it is just teaching your model how to be a better chat model. And that's the same for creating legal based open source chatbots. So when you're doing instruction fine tuning there, you just fine tuning it on more examples of a specific domain, let's say finance in FinGPT, so on and so forth. You can see a few examples here. This is what you sort of expect. So it's just questions and their answer, and these could be a part of a conversation. So you could have parent ID. Again, for anyone interested, even if you just look this up, H2LLM Studio, it's under the like button as well. But if you just look it up, it's fully open source. You can try this yourself, and you'll get this exact interface. But once you've loaded in the data set, you can then sort of load in your backbone that you care about. So if you were looking at the textbooks data set, right, they sort of created a 1.3 billion parameter model. We could select the exact same backbone here, right? And you would imagine that the data set would then be those Pythonic exercises that we had created earlier, right? You just load those in. And by the way, if you want, you can also like select a custom backbone here that's based on your own checkpoint. I'm just using a pre-trained one here. After this, through just the menu, you can set all of the possible settings you care about. So you point it to the prompt column, the answer column. You give it the special tokens, which helps it understand how to read these answers. From there, you can set the length of the prompt, the length of the answer, the maximum length. This has now been extended to a billion. I'm just laughing because this paper came out yesterday that promised showcasing up to a billion tokens, and they sort of only tested up to 32,000. So that paper received a lot of criticism, and I was just reading through it, and I thought, this is quite interesting because they only showcased until 32,000. So if you want, you can set the slider to whatever your GPU allows. And once you've done all of that, you can set LoRa fine tuning to be on and set the specific hyperparameters around that. There's a lot of settings to play around with, but once you're happy with those, you can run the experiment and you then start creating your specific LLM. And once you've done that, you can get this really nice graph and you can get insights around where a model is behaving the best or worst. You can even chat with it on the prompts that it sort of fails or on the prompts that you expect it to fail. And then you can really get a feel for how these models behave. So again, this is fully open source. You're welcome to try it. This is one way of creating such domain specific models. Oh wow, we have a legend in the chat. I don't know why Shivam is joining this live stream so late, but thanks for joining, Shivam. Ayush is an a really good friend and a colleague of mine, ex-colleague of mine. He's just pulling my leg. From what I know, he's already deployed a LLM on a GitHub repo. That's all I'm allowed to say. So he's just pulling my leg here. Cool. So the last paper I covered was this knowledge graph one. And you can read this paper out if you want. It sort of really talks about how you can create these three different categories of knowledge graphs. Let's take a look at FinGPT, which was the first open source financial LLM, at least to the best of my knowledge. So Bloomberg GPT was the first financial LLM, but that wasn't open sourced. FinLLM is the first open source one. And inside the paper, they really talk about data. So it takes a data centric approach. And it starts by having a fine tuned LLM for financial market, and then also having like the streaming data coming in from every day. So they propose this like 4 layer architecture where you have a data layer, a data engineering layer, LLM layer, an application layer. This layer sort of contains a fine-tuned llama. Or if you want, you can just turn that off and enable GPT-4. So then it just interacts with these data sources that have been collected earlier. What basically these are collections of extensive data sets. The paper goes into a lot of details, and then you have some very simple filtering being applied. After that, you sort of apply a very smart prompting to perform different applications. Now these could be day trading, these could be different applications, like you could pick sentiments or pick help predict the directions of the market, so on and so forth. So this very simply is FinGPT. That is the title of the paper. Open source financial large language model. If you want to look it up. I think Sarkan, we had just interacted on Twitter right before the live stream. But yes, using LLM Studio, the tool I just showed you earlier, you could definitely teach any language model a new language as well just by fine tuning it. Like I had showed earlier, so you could just, all you need to do is load in those charts and have those special tokens. Just load it in a data frame, concatenate those special tokens at the beginning and end of the sentences, and then you can create a model that can speak any language. Cool. So now we're looking at tiny stories where they sort of, now this is a cheeky comparison because they show 33 million model outperforming a 1.5 billion one, but they're sort of comparing a simple model against GPT-2 XL on a very specific data set. So this is a catchy headline for sure, but it's also like, very niche comparison of being able to write English. Why is this interesting for me to cover today? Because it teaches a very interesting thing, using GPT-4 for high quality data generation. And then you train these models on this synthetic data that gives like this very performant models. So it showcases the power of clever prompting and curation. Basically, they're very careful about having this data set as being derived from children's vocabulary. So what they do is they ask GPT-4 to create a data set consisting of words that very young learners would use, and then they sort of fine tune their model, or just they train their model on scratch from this. After that, they use GPT-4 to evaluate these models and give scores to these things. But we'll cover the paper in a bit more detail just in a few minutes. The key thing here was the very smart prompting. So let's say they had collected uh, I don't know, data set, data frame, whatever you want to call it, of children's words, right? Like very young people would learn from. And then they would ask GPT-4 to, hey, use these three words selected at random and write a sentence about it, write a story about it. And then you train a model on this. Just this approach shows that you can create a very small model that's really good at English comprehension and English writing. Why is this? Why is this interesting? That's because you could follow this approach for multiple smaller domains as well, right? Or having this training approach, not even the synthetic dataset approach, could help you create very domain specific models. So you could think how, let's say, a young trader learns, right? Like how, so I don't know how to day trade or even trade for that matter. I would go to YouTube, pick up a bigger video, start from there, maybe buy a book, I don't know, something like that. So you could have the data set arranged in this fashion and then fine tune your mini LLMs or just a LM that's small enough to be deployed as an assistant model. So in that sense, this was an interesting paper. Cool. It's called Tiny Stories: How Small Can Language Models Be and Still Speak English. Now let's jump into understanding these papers in a little more detail. So I've given the meat of 7 papers. I've sort of accomplished my goal today. All right, I didn't mess it up. Usually I like set a very ambitious goal and we have to end early. Today we've covered the summaries. Now I'll give you the meaty details around the exact details. So for anyone that's curious, please keep the questions coming. And now let's try to cover a lot more details around these papers. So let's start with, we'll just go in this order that it's been loaded in. And let's start with FinGPT. And let me pick a highlighter. So again, to recap, it takes this data-centric approach. And they keep mentioning that, hey, it's about democratization, it's about transparent resources, so on and so forth. And then they use LoRa fine-tuning, which when the paper came out was just, I think, being picked up. Now it's like very common. I showed the tool earlier, which H2 LLM Studio has just this built in as a like graphical option. And then they applied to robo advising, algo trading, and low code development work. I'm just curious if I wrote this one correctly, but I'll just double check and we can get back to this. So this is what the paper does broadly. Once more, they talk about their data centric approach. It adopts a data centric approach and implements rigorous data cleaning and pre processing methods for handling various types. And then they talk about how they've kept the data high quality. Broadly, it has these four layers, which we'll just see in another page. Let me just scroll down to the architecture to give you all an overview of this. So here's the exact architecture of this paper. And they've sort of written about this earlier, so that's why I just scrolled past it. I have read the paper, all right. I'm not reading it live. So I did read it before writing about it. I didn't use GPT-4 to summarize it, contrary to what many people believe. I might have now and then, but not this one. All right. I'm just, I'm just, I'm just trying to justify something that I haven't even received an allegation for. But it has these four layers. The data source layer. Let me switch this color. The data engineering layer, the LLM layer, and application layer. Inside of the data source layer, they have these different sources that are being collected. So you have news, social media, SEC filings, so on and so forth. This is based on the US market. So that's why I see these names here. Oops, sorry about that. I was just trying to undo the highlighting and it just scrolled me up. I've messed this up, but this just says SEC, NYSE, and NASDAQ. So you have all of these sort of data sources that then bleed into this data storage or this data warehouse. From there, you perform all of this data engineering, which includes prompt engineering to feed it to the models. And this basically means prompt engineering here refers to that, hey, GPT-4 or whatever, here's a bunch of data sources, so on and so forth. News from, I don't know, 2008. Use the housing market crisis to predict 2020 crisis, something like that, broadly speaking. This then sort of feeds into, you have the option of working with LLM APIs or trainable models. And then these sort of trainable models are, of course, fine tuned using LoRa. And this second approach was really cool. So, this is also why I wanted to actually go through the papers. We have RLHF, which is reinforcement learning based on human feedback. So, basically, you have a reward model that sort of gives a higher score if a human would prefer the answer. Here, they use RLSP, reinforcement learning for stock price. So the stock price becomes the reward model, which at least I thought was really cool. So this is then fed into the LLM, and then you have all of these applications that it sort of gets applied to. So this was FinGPT. We can go through the evals and whatnot, but I think that's it for the architecture. Let's take a look at Chat Doctor now. And this I'll keep brief because it's just a fine tuning approach. But this came out around April, so very early LLM days in that sense. All they do basically is they fine tune Alpaca onto 100K patient physician conversations. Sorry about that. Or 100K patient physician conversations that they've collected from like a consultation website, right? So first they do a fine tuning of the Llama. I think it's 7 billion model. So they fine tune it using the Alpaca dataset. Alpaca, I don't think has been ever released. So that's why they fine tune on this. And then they also fine tune on the medical 100K examples that they have sort of collected. After that, they also connected to an external database. So this is another trick that was just being discussed at that time, right? Which was having a fine-tuned LLM and then connecting to external DB. This is very common knowledge now. I'm sure everyone in the chat is sort of saying, why are we even covering this? But at that time, it was quite innovative. And this was also one of the first papers to show like a domain-specific LLM. So this is the exact name of the data set that they have collected. And throughout the paper, they give a lot of examples. I didn't particularly go through this because I wasn't like personally curious about, hey, is it like picking the correct diagnosis, disease, so on and so forth. I just assume the cherry picked examples would be good enough. And they did use Llama 7 billion. So that's about the detail for this paper. You can go through it. Again, it's very, very common knowledge now how to create this specific fine-tuned models using LoRa fine-tuning or PEFT. So I just thought I'll give it an honorary mention. Let's take a look at clinical GPT now. This is another, obviously, medicinal based large language model. And then they talk about, so this is also from early June, which is not even a month old, but like decades as per LLM standards. So the challenges with any domain specific or specifically medicine ones are factual inaccuracy, reasoning, and lack of grounding. So to deal with that, they sort of create clinical GPT, which is based on, I'm forgetting now, so I'm trying to find the exact paragraph. Right, it's based on Bloom. I just recall that. Let me find the exact sentence. Somewhere around here, it's mentioned that it's based on Bloom 7 billion, I believe. Maybe they mention it later. But the cool thing about this paper is they sort of do the entire pipeline. So it's not just fine tuning on examples or chart examples. They sort of do the entire pipeline of even collecting knowledge graphs, Wikipedia, online corpuses, and then further doing a supervised fine tuning and also having a RL model built in. The catch is this is just like a Chinese medical answer and question and answer data set. So again, I had to use my fluent Google Translate skills, but this was also sort of very popular paper at that time. So if anyone remembers, and shout out to anyone who remembers that live stream when you all had caught me mess up causal and casual language models, right? I'm not making fun of the authors. I just found this spelling mistake to be funny because this made me remember that. So if anyone remembers when I had messed up during the NLP live stream, even experts mess up, all right? So please don't pick on me. This also gives a very interesting shout out to the WebGPT paper, which is another domain specific one that sort of teaches models to do web crawling better or navigate websites better. So here they mention, and I did remember it correctly, that it's based on Bloom 7 billion as the base LM, and they give the exact details of how this was fine tuned. So after here, it's just, hey, we collected this data set very carefully, so on and so forth. Nothing for me stood out. One quick fact that it's based on Bloom 7 billion, but the Blue score for the medicinal fine-tuned model is worse than the original model. So they say clinical GPT comes second to Bloom 7 billion in terms of Blue 2, 3, and 4. So this was quite interesting that the model sort of loses these capabilities a little. But this was clinical GPT. And again, not many details was pointing out here. Let's take a look at the next one, the Chat GPT for robotics paper. And this one for me was quite cool because they showed these like very, very cool examples. And I'll just showcase some prompts that were really cool for me. One thing worth pointing out, inside the paper, they keep saying, hey, uh, we need to be careful about how to get the model to sort of follow external APIs. So I just assume this was before the official OpenAI update to better API following, right? But here's an example. So they say, imagine they're talking to the agent. They ask it to be a household robot and it's supposed to make an omelette. And then they tell it, hey, these are the functions you can work with. So you can locate the object, go to location, pick up and use that item. So it by itself sort of works with this abstraction level and is able to come up with, okay, the objects would probably be in the fridge, and then I need to find oil, I need to find eggs, I need to crack these eggs, place them in the pan, so on and so forth. Now, mind you, all of this is based on GPT 3.5. My understanding is 4 is much better with like broad world understanding. So if they had used 4 at all here, that would have been like even cooler or even better with these like replies. But they just use 3.5 here. And let's take a look at another example. So then they sort of restrict it to follow these examples better, or here they ask it to even write a high level function. Later, they show that this is also able to come up with OpenCV examples for drones, so on and so forth. But as you can see, this goes further and further to sort of even showcase that here's a servoing uh, robot. Sorry, serving approach towards a basketball. I thought this is a servo motor. That's why I got confused for a second. But this is a robot that is serving a basketball inside a court. And from just that prompt, it's able to come up with this entire OpenCV function to work with that. And then they also show this for drones, for robots that work inside homes. And finally, they also connect this with like a simulator. This is open source and it is there in the repository. So I did check. It's not coming soon. It is there right now. You can find all of the details inside the paper. But this is, again, LLMs being applied to robotics. So that's all I wanted to cover from this paper. There's not much I want to highlight from knowledge graphs. Unless there is interest or any specific questions, I'm just going to scroll past this. So, for the discussion happening earlier, this is the overview of the ChatLaw paper. Now, again, this is based on Chinese datasets. So that's why at least I'm not able to read any of this. But you have this main LLM that you sort of interact with. From here, the embedding lookup happens after extracting keywords. And from this vector DB, you get the sort of special codes that are then processed by the ChatLaw model to give you responses specific to that. Now, all of us had a very quick discussion if there's any details around the keyword LLM. I don't think there are. But just to highlight the entire retrieval approach, here's how they do it. They have a BERT model for embedding and keyword extraction. I think this answered the question, everyone. So we all were curious. I think Rajesh had asked that question and Maruti had asked that question. We're just using a BERT model for keyword extraction. BERT model for keyword extraction. It's mentioned right here. Cool, we answered the question from earlier. I'm quite happy today. Usually I have to go back and write a comment. Not today. So it's a BERT based model that extracts keywords. Then they initialize the entire database. And let's say they have M number of examples in there. They initialize the scores, which basically compares similarity. Now they extract the keywords, and then this is fed to a BERT model, which then generates a keyword vector. After you have that vector, you just do a very simple embedding lookup. And then the top k examples are returned based on the cosine similarity score. So that's the interesting part from this paper. And now we are on to the final paper that I wanted to cover for today, which is textbooks are all you need. Um, I believe we've covered this already, but I'll briefly highlight the interesting part here. So this is to create models that perform really well with Pythonic um, exercises, specifically exercise of writing code based on doc strings. And the cool thing, again, I had covered this in a previous live stream. Literally, if you go onto the channel, you can find a thorough discussion around it. But 5.1 sort of comes in third compared to much larger models. And the first one being GPT-4, which is much, much, much larger, or Wizard Coder, which is still quite larger. And there as well, you can see that it only outperforms Wizard Coder is better in one of the two settings. The MBBP stands for mostly basic Python programs. So to quickly highlight what was going on here, you have the dataset called the stack, and you have a dataset called code textbook, which is a collection of GPT 3.5 curated examples plus open source repositories. You train your original model on this, and then when you fine tune it on exercises, it starts to show emerging abilities. And you can see the difference in performance across all models. So they do this for small number of hours, then they compare it for more GPU hours and more tokens, so on and so forth. So they compare the 350 million model and the 1.3 billion one. The 1.3 billion model performs really well. And it's quite funny to say that, but it's only trained for 1090 GPU hours, which at least in LLM world is really small. So that was the cool thing, and that sort of gave these models the emergent ability to write really good code, really good examples, and was able to perform really well. I think we've covered the 7 papers I had set out to. So let me just suggest some homework for everyone. This is the first for me to cover 7 papers in one live stream, but I'm quite happy we were able to do it. So again, very simple suggestions. I usually leave the suggestion. No one follows them. I still suggest these. If you're interested, write about these papers on the internet. I found that really helpful in my career, and that sort of sends a signal to anyone that hey, you actually know about this. And tag me with a chai emoji, preferably. I'd be happy to amplify whatever you write about. Also, consider checking out H2O GPT or LLM Studio. It's linked under the like button. That's it for today. I'll just check if there are any questions in the live stream. So I'll wait for 30 seconds. If not, we'll wrap up. Cool. We can wrap up. Thanks everyone for joining. We'll keep meeting every weekend, and I'll try to keep covering at least one paper. Could you enlist some ways to handle hallucinations? I'll write about it. So I'll write about it. Let me collect all my thoughts and I'll write about it. It's I don't think it can be covered in under 5 minutes. Um, no, these are pretty much it. If any other ones pop up on my radar that are worth covering, I'll write about them. So, by the way, side note for anyone interested, I read at least 7 or 8 papers every day, and I only share like 3 or 4 a week. So I'm like very strict about filtering out the ones that I don't think are high quality for anyone else to learn about. So maybe I'm just like leaving out a lot of interesting ones, but I've shared all the ones that are high quality in my opinion. Cool. I don't see any other questions. Leave a comment if you have any questions. Thanks for watching. I'll see you all next weekend.